Hello everyone, welcome to Mthobisi Mhlongo Mathematics and Physical Science YouTube channel. In today's question, or in today's episode, we are looking at one of the November 2020 papers for Physical Science, paper 1. And our question is question 3, which is vertical projectile motion. In short, it's sometimes called VPM. So in VPM, we're looking at motion that happens in vertical. As in grade 10, the introduction of motion in a straight line, and then in grade 11, they start to introduce a bit of motion in vertical of axis. So today's question says that a small ball is dropped from a height of 2 meters and bounces a few times after landing on a cement floor. And we ignore air friction, and there is a position time graph which is not drawn up to scale, that represents the motion of the ball. Now, what we can take from this graph is that we're given the position where the ball was, where it started, and if I can just redraw the whole graph underneath here so I can describe perfectly. So we have this graph here, starts here, and then there's a gap, there's one that starts here, and then there's a small one that starts here. Now, the starting point of the graph here is 2, and then this point here is around 1.85, and then this point here is around 1.2. And at this point here it's 0.64, and here 0.67, here 1.90, and here 1.97, and then t. This is position in meters, that is x, and time in seconds. So basically the ball bounced or fell off, I would say, or it was dropped. So this ball was dropped from here. It was dropped from here, went here, then it took a jump to around here, went to maximum height, and then it took another jump, goes to maximum height, and came back down to the ground. So let's say this is our ground level. And that is why we see our graph with mountain looking like Adidas or something. So yeah, here's what we should take out. We will be using these formulae, which are called the equations of motion. The first one, you use it when you have a final velocity and an initial velocity and an acceleration and time. Second one, a final velocity, an initial velocity, acceleration, and um, a displacement, either in the horizontal or in the vertical. The third one, it's delta x is equal to vi's delta t plus half a delta t squared, or delta y is equal to vi delta t plus half a delta t squared. That one you use it when you have displacement, v initial, and time. And the last one, to find displacement, or being written in the form of displacement, you need displacement in the horizontal or in the vertical, with initial velocity, final velocity, and the time it took for the displacement to be covered or changing in x, basically. But that's displacement. Right. Now, the first question wants us to define the term free fall. That's 3.1. Free fall. If we define free fall, we can say this is motion of an object under the influence of gravity only. Or you can say this is motion of an object where the only force acting is gravity. Alright, next question. Says use the graph and determine. Now, the time that the ball is in contact with the floor before the first bounce. So if we go back to our new graph here that we drew, it took this time from here to here for it to hit the ground. And after it hit the ground, it sat for a little bit of seconds until it went up in position. You can see it went up to its maximum position. So if we may go back to the question, it says the time that the ball is in contact with the floor. So basically, they want the time in between here, which is from when it hit the ground and when it left the ground. So how much time between this space? So easily you can just look at the time when it left the floor and the time when it hit the floor, and then you get your calculations. So 3.2.1 delta t, that'll be 0.67 minus 0.64, which is equal to 0.03 seconds. So it was in contact with the floor for 0.03 seconds. Now, 3.2.2. The time it takes the ball to reach its maximum height after the first bounce. So now the first bounce has happened. First bounce happens here, where I've jotted green. Then maximum height is somewhere here. And maximum height, if you check here, the time it takes from first bounce to maximum height should be equal to the time it takes from maximum height to second bounce, or when it hits the floor for the second time. Because this makes a what do you call it? A set phase parabola. And you know a parabola is symmetric, so the time it takes in the x-axis should be equal from maximum position to the ground in both sides, which is from ground to maximum and from maximum to the ground. So what can we deduce here? You are looking for the time it takes the ball to move from 0.67 up until this point here, which we can call a y. Or you can, by virtue, look, say we're moving from here all the way up to here, but I'm looking for this point, and that's a midpoint. So you find the length from 0.67 to 1.90. How much is it? So at 1.9 minus 0.67, that is your time it took for it to get back to the ground, right? So delta t here would be, let me say 1.9 minus 0.67 would be 1.23 seconds. So if it took it 1.23 seconds, what is the half of 1.23? Because we're looking for the midpoint, and the midpoint is half. So we divide this one by 2, we get 0.615 seconds. Now, 0.615 seconds, it looks um, it looks um, it looks as if we moved from 0.67, then we moved 0.615 to get to maximum. So if this was maximum, the time here it took it's 0.67 plus 0.615 and another 0.615 to get back to the ground. And then if you add these two, you're going to get a 1.9. I hope you guys will understand this. But if you are taught to do your calculations, that is also fine. Now, we are starting here with a velocity that we don't know. We go up to maximum height, which is, we can go back to the question, which is 1.85 above the ground. So we go back to delta y, which is 1.85, and we are at v final, which is equal to 0, and we know we are going up, so up will be positive and downwards will be negative. And now we are under the influence of an acceleration, which is what? Negative 9.8, because it's going down. It's pulling the object to go down. So what formula combines VI, the formula that combines VI, VF, delta Y, and A is this second one here. Vf squared is equals to Vi squared plus 2a delta x. So our unknown is Vi. So we say Vf squared equals to Vi squared plus 2a delta y. And our Vf squared is 0 squared, which is equals to Vi squared. Well, why would we want to know um, the V initial? The V initial is going to help us get the time it took from here to here. That's how it's going to help us. The time it took from here to here. Because someone may ask, why would we calculate VI when we are not asked of VI? All right. Plus 2 times negative 9.8. Delta Y is a 1.85. And then if I punch in a calculator, we get 0 is equals to Vi squared minus 36.26. Then if we move 36, negative 36.26 to the left hand side, it becomes a positive 36.26 is equals to Vi squared, and we have to apply the square root on both sides so that we get our Vi to be equal to 6.26 0.02 meters per second. Now, if if we if we have our VI, which is 6.02 meters per second, we will have now the V final, which is 0 at maximum. Now, VI is equal to 6.02. VF, which is the maximum velocity, is at 0 meters per second. And then now we want the time. We have the displacement, which is 1.85, but we want the time it took. So if we go back to the equations of motion, which one combines those four? V initial, V final, delta Y, and time. V initial, V final, delta Y, and time. We're looking for time. So we can choose quite a lot of options here. Let's also add acceleration. Acceleration is negative 9.8, but let's start without acceleration. So you have um, delta y is equals to Vf plus Vi over 2 delta t. Delta t. Now, our delta y is 1.85, and our V final 0, and our Vi, which was calculated to be 6.02 all over 2. And then our delta t is what we're looking for. When you say 6.02 divided by 2, or we just divide on both sides by 6.02 divided by 2. In your calculator, all of this can be calculated easily. You just write it as it is, 6.02 all over 2. And then this and this will go away, and you get your delta t, which is equals to um, 1.85 all over 6.02 over 2. Then we get 0.615. 0.615. We said there is another method that you can use, which will be using Vf equals to Vi plus A delta t, whereby we are now using A. Here we have 0 is equals to 6.02 plus negative 9.8 delta t. You take this to the other side, it becomes a 9.8. Delta t is equals to 6.02. Divide both sides by 9.8, 9.8, and then you get delta t is equal to 6.02 over 9.8? 6.02 over 9.8. You still get 0.615. 0.615. That's seconds. Okay, so there's many methods and options that you can choose from, depending on which one do you opt for. Now, the next one wants us to calculate the speed or use the graph and determine. to get the speed at which the ball leaves the floor. So already we have calculated that, but let's redo it again. The speed at which the ball leaves the floor at first bounce. So we're looking at the speed here, which we were calculating just now. That means we'd have to repeat the calculation. So the ball hits the floor at 0.64, leaves the floor at 0.67, gets to maximum height, which is 1.85 delta y, and we want the V initial when it leaves the floor. But do we have the time? You can do a vice versa. So it'll get back here at 1.9. So what can you do? You do the inverse or the opposite. You can say, okay, 1.9 minus 0.67 all over a 2. You get your 0.615 or 0.62 seconds. Then with this time, I know the time it took from here to here. It was 0.615 seconds. So now you have time, you have delta y, you are looking for V initial, and you have V final. Any formula that can combine all of those, and you have A. Are you going to use the time? Are you going to use A? I'd prefer using A because time is calculated. So to limit the calculated values. So this will be negative 9.8 meters per second square. VF will be 0. This one we're looking for. And the height will be 1.85. Now, if we use VF squared equals to VI squared plus 2A delta Y, we do the same thing. 0 squared is equals to VI squared plus 2 times negative 9.8 times 1.85. And then 0 is equals to VI squared minus 36.26. Then 36.26 is equals to VI squared. And then if we take the square root on both sides, we get that VI is equals to 6.02 meters per second. Okay. Or you can choose to use time. If you choose to use time, you're going to say VF is equals to VI plus A delta T, the time that we calculated. So that 0 is equals to VI plus negative 9.8 times 0.615. And then if you take that to the other side, VI is equals to 6.02 meters per second. Okay. The last question. The time t indicated on the graph. The time t indicated on the graph. How do we get the time t indicated on the graph? Well, to get the time t indicated on the graph, we would use the same method that we have used. So at 1.97 seconds, the ball leaves the ground, goes to its maximum height. Then it gets to time t, which we don't know. But at maximum height, delta y is equal to 1.2 meters. And we don't know the initial velocity that it leaves. So what do we say? We say we have VI, we're looking for it. Do we know how much time it took? No, we don't. So we can't use time here. But we know VF and we know delta Y and we also know acceleration, which is minus 9.8. VF was 0, this is 1.2. Formula that combines that is our infamous VF squared equals to VI squared plus 2A delta Y. Now 0 squared is equals to VI squared plus 2 times minus 9.8 1.2. And when we do our calculation, we get that 0 is equal to VI squared minus 23.52. Take 23.52 to the left hand side, it becomes 23.52 positive equals to VI squared. Then we take the square root on both sides, and then VI is equals to 4.85 meters per second. So it leaves the ground here with 4 point, the velocity of 4.85. Now we want to know how much time did it take for it to move from here to maximum. So this means now we have our VI 4.85 at VF is at maximum 0. We have also our acceleration negative 9.8, things that are reliable. And then we're looking for the time it took for it to move. So we can go to the famous uh, easy equation. The first one, Vf is equals to Vi plus a delta t. 0 is equals to 4.85 plus minus 9.8 t, or delta t. So we take that to the left hand side, it becomes 9.8 is equals to 9.8 delta t is equals to 4.85. We divide both sides by 9.8, divide both sides by 9.8, and then delta t is equals to 0.49. Now, the 0.49 is from 1.97, you go 0.49, get to maximum height, and then go you go 0.49 and you get to t. So basically t is equal to 1.97 plus 0.49 plus 0.49, just like a number line. And then this is equals to 2.95 seconds. Now, sorry for a few glitches. I'm working from school and there were a few disturbances. Please like, watch, and share, subscribe. See you in the next video.